that is a ringனா என்ன அப்படின்னு பார்த்தீங்கன்னா ஒரு நான் எம்டி செட் ஆர்ன்றது is called the associative ring இல்ல ring அப்படின்னு நாம சொல்லணும்னா that is satisfying the some condition. என்ன condition அப்படின்னு பார்த்தீங்கன்னா the non empty setன்றது with respect to the additionல abelian group இருக்கணும். Okay, because of this is the two operation. இதுவரையில group theoryல ஒரே ஒரு operation பார்த்திருப்போம். இங்க two operation. The same non-empty set with respect to multiplicationல and semi group இருக்கணும். இதுல abelian group இருக்கணும். This is the semi group. அப்படி இருந்ததுன்னா that is called the ring. With distributive property. இதுல வந்து abelian r plus abelian r dot semi group and distributive property. either மொத்த டோட்டலா 8 properties வரும். 8 properties satisfy பண்ணாச்சுன்னா இந்த நான் எம்ப்டி செட் is called the ring அப்படின்னு சொல்லுவோம். So first of all பாத்தீங்கன்னா 5 property non empty set with respect to addition, that is closure and associative, identity axiom and inverse axiom. Inverse into the negative of the number and commutative property. And with respect to multiplication, closure and associativity. And distributive law with respect to addition and multiplication, and that is a dot b plus c equal to a dot b a dot c, and another form b plus c dot a equal to b dot a c dot a. இல்ல இப்படியும் எழுதலாம் a plus b dot c equal to a dot c plus b dot c ன்னு எழுதலாம். இதுவும் கரெக்ட் தான். So இந்த ரெண்டு property is called the distributive law. So distributive law, the non-empty set with respect to addition abelian group, with respect to multiplication semi group. Then the non-empty set is called the ring. Non-empty set ன்றது ring அப்படின்னு சொல்லுவோம். Okay. And what are the types of ring? That is a ring with unit element. என்ன அர்த்தம் unit element னா என்ன அர்த்தம்? Okay, multiplicative identity ன்னு அர்த்தம். What do you mean the multiplicative identity? 1 is the multiplicative identity. So 1 ன்றது multiplicative identity. So அந்த 1 ன்றது exist ஆச்சுனா ringல with unit element means there exists one belongs to R such that a dot 1 equal to 1 dot a equal to a. That means multiplicative identity exist ஆகுதுன்னு அர்த்தம். அப்படி exist ஆச்சுனா ring with unit element அப்படின்னு சொல்லுவோம். And commutative ringனா என்ன அர்த்தம்னா ring வந்து already R plusல commutative property with respect to additionல commutative property satisfy ஆகும். With respect to multiplicationல commutative property இருக்கலாம் இல்லாமலும் இருக்கலாம் ringக்கு. And with respect to multiplication commutative property satisfy ஆச்சுனா that is called the commutative ring அப்படின்னு சொல்லுவோம். So commutative ring with unit element என்ன? The ring வந்து satisfy the multiplicative identity axiom and multiplicative commutative property. இது ரெண்டு satisfy ring with commutative ring with unit element அப்படின்னு சொல்லலாம். The field அப்படினா என்ன அப்படின்னு பார்த்தீங்கன்னா fieldன்றது for every non-zero, இப்போ commutative வந்துடுச்சு, identity வந்துடுச்சு, இன்னும் one more வந்து with respect to multiplication என்னதுன்னு பார்த்தீங்கன்னா inverse, multiplicative inverse. அந்த multiplicative inverse exist ஆச்சுன்னா commutative ring with unityல, commutative ring with unityனா already ringனாவே semi group with respect to multiplication. அதில் unit elements சேர்ந்துடுச்சு, commutative property சேர்ந்துடுச்சு. இப்போ every non-zero element as a multiplicative inverse na, that is called the field. So field na என்ன சொல்லலாம்? The set of ஒரு non-empty set வந்து நான் field நான் சொல்லணும்னா R plus வந்து abelian group இருக்கணும், R dot ன்றது abelian group இருக்கணும். That is for non-zero elements, and distributive property இருக்கணும். இப்படி இருந்ததுன்னா that is called the field. அதுதான் அது field. இதுக்கு எக்ஸாம்பிள் பார்த்தீங்கன்னா ரிங்குக்கு முதல்ல எக்ஸாம்பிள் பார்ப்போம். ரிங்குக்குனா செட் ஆஃப் இன்டிஜர் இஸ் கால்டு த ரிங். ஓகேவா? தட் இஸ் இசட் பிளஸ்ன்றது எப்ளியன் குரூப்னு தெரியும், இசட் டாட் இஸ் செமி குரூப்னு தெரியும், டிஸ்ட்ரிபியூட்டிவ் ப்ராப்பர்ட்டி சாட்டிஸ்ஃபை ஆகும். ஸோ திஸ் இஸ் எக்ஸாம்பிள் ஃபார் த கம்யூட்டேட்டிவ் ரிங் வித் யூனிட்டி. அண்ட் ரிங் ஆஃப் இன்டிஜர் மாடுலோ என். மாடுலோ என்னன்னா என்ன அர்த்தம்னா தட் இஸ் zn என்றது 0 1 2 and to n minus 1 எழுதலாம். தட் இஸ் ரெண்டுத்தை ஆட் பண்ணிங்கன்னா அது மாடுலோ nல இருக்கிற ரிமைண்டர் நம்ம போடணும். அந்த ரிமைண்டர் தான் 0 1 to n minus 1 மாடுலோ nனா. ஓகே, மாடுலோ 6 இருந்தால் 0 1 to 5 தான் வரும். மாடுலோ 7 இருந்தால் தட் இஸ் 0 1 to 6 னு வரும். Okay, so this is the ZN. Okay, ZN is a commutative ring with unity 1, unity element 1 இருக்கு. So that is the commutative ring with unity. For example பார்த்தீங்கன்னா Z6, இதனுடைய particular case Z6 0 1 2 3 4 5. This is a ring but not an integral domain. அது பின்னாடி பார்ப்பீங்க not an integral domain ன்றது. Okay, so this is the 5 elements. This is a ring. That means Z6 plus ன்றது abelian group ஆகும், Z6 dot ன்றது semi group ஆகும் with the commutative property satisfy ஆகும் and commutative property distributive property satisfy ஆகும், commutative property satisfy ஆகும், unity element இருக்கு. So this is the commutative ring with unity அப்படின்னு சொல்லலாம். அதே மாதிரி ring of real valued function அப்படின்னா என்ன அப்படின்னு பார்த்தீங்கன்னா the f of x, r denote the set of all function from x to reals r. F, g belongs to f of x, r. Define the f plus g of x equal to f of x plus g of x. F g of x equal to f of x g of x. So f of x, r is a commutative ring with unity. And this is the example, the collection of function. Other ring of polynomials means r of x equal to a0 plus a1x plus a2x square an x power n, a belongs to r. This is an example for commutative ring with unity. That means இதுக்கு என்ன ஆகும், r of x plus with respect to addition it's abelian group, with respect to multiplication is a semi group, and a distributive property, commutative property, and identity axiom with respect to commutative property and identity axiom with respect to multiplication is exist. So this is called that this is a commutative ring with unity. What is the identity element with respect to multiplication? Constant polynomial that is 1 ன்னு எடுத்துக்கலாம். Constant polynomial that is equal to 1. And a ring of 2 by 2 real matrices that is called the M2 of R ன்னு சொல்லுவாங்க. M2 of R னா the collection of 2 by 2 matrices, the entries are belongs to the real number. So இதனுடைய identity element with respect to multiplication identity element பார்த்தீங்கன்னா identity matrix. Okay, but this is not commutative in general. So it is the example for non-commutative ring. This is the example for non-commutative ring. அதே மாதிரி zero ring ன்றது என்ன அப்படின்னு பார்த்தீங்கன்னா r equal to 0, only the 0 with operation. This is called the zero ring example. So இங்க பார்த்தீங்கன்னா 0 plus 0 dot 0 equal to 0, ring is called zero ring. Okay, and 0 equal to 1, it serves the trivial example of the ring, but not a ring with unity. So distinct from 0, that is distinct from 0 ன்றதுனால. So here 0 is not equal to 1. So this is some summary from the ring, that is Z ன்றது commutative ring and commutative ring with unity, and Zn ன்றது commutative ring with unity. R of x ன்றது collection of polynomial function, commutative ring with unity, and the collection of 2 by 2 matrices with real entries, not a commutative ring, and but it is a unity. And this is the zero matrix, it's a commutative ring with unity, and unity element, that is not a unity element. So these are simple examples. And so r equal to z is the integer, the collection of integers. This is once again the collection of even integer, that is the set of integer commutative ring with unity in the ring. What about the even integer? Even integer means that is the ring, commutative ring, but no unity element, because of 1 is not belongs to 2z. It's a very simple reason. So r equal to the rational number, set of rational number. It is a commutative ring with unity, and also every non-zero element has a multiplicity inverse. So this is a simple example for the field. Q is the field. Okay, அதே மாதிரி integer modulus 7 பார்த்தீங்கன்னா 0 1 2 3 4 5 6 is that 7. Okay, 7 is the prime number. So this is the addition. Already நான் பார்த்த மாதிரி this is the commutative ring with unity. So இது எப்படி டிஃபைன் பண்ணோம்னா, ரெண்டுத்தையும் ஆட் பண்ணால் ரிமைண்டர் வந்து என்ன வருதோ மாடுலஸ் 7ல் ரிமைண்டர் வர்றது தான் கலெக்ஷன். அப்படி பார்த்தா 0 1 2 3 6 தான் வரும். ஸோ இங்கே பார்த்தீங்கன்னா ஆப்ரேஷன் பார்த்தீங்கன்னா 4 + 5ன்றது 7னா 4 + 5 = 9னா 9 modulo 7ன்றது 2. and 5 into 3 15 15 modulo 7 that is 1. Okay, so அப்படி பார்த்தீங்கன்னா R is a commutative ring with unit element இருக்கும், and this is a field because of every non-zero element has a multiplicative inverse. Z6 க்கு அப்படி இருக்கா, that is Z7 க்கு வந்து every non-zero element has a multiplicative inverse, that is the 1. So this is an example for the field, finite field, and this is the example. So 2 into 4 8, 2 node inverse என்ன பார்த்தீங்க multiplicative inverse 4, 3 node multiplicative inverse 5, 4 node multiplicative inverse 2, 5 node multiplicative inverse 3, 6 node multiplicative inverse 6. So this is a form an abelian group under multiplication, and R is a finitely many elements, so therefore this is an example for finite field and Gauss field அப்படின்னு சொல்லுவாங்க, Gauss field. And another example பார்த்தீங்கன்னா set of integer modulo 6, set of integer modulo 6 and 0 1 2 3 4 5. இங்க 6 ன்றது prime number கிடையாது, 6 ன்றது prime number இல்ல, it's a composite number. So Z7 ன்றது field வருது. Okay, that is satisfying. So இங்க பார்த்தீங்கன்னா the same idea தான் moduloன்றதுனால modulo 6 ன்றதுனால இங்க பார்த்தீங்கன்னா Z6 plus ன்றது abelian group with identity element 0 னு வரும். Multiplication modulo 6 ன்றது associative and distributive is satisfied. The Z6 is a ring under this operation. Z6 ன்றது ring னு சொல்லலாம். Okay, and multiplicative inverse எல்லாத்துக்குமே exist ஆகும்னு சொல்றாரு. It's a zero divisor இருக்கும். இங்க 2 into 3 ரெண்டு element மல்டி பண்ணீங்கன்னா 6, 6 modulo 6 ன்றது 0. So there is 2 is not equal to 0, 3 is not equal to 0. So non-zero element ரெண்டதை மல்டி பண்ணா 0 identity element வருது, 0 வருது. That is a 6 வருது. Okay, that is the product is 0. So therefore what is the conclusion அப்படின்னு பார்த்தீங்கன்னா this is a zero divisor அர்த்தம். Okay, but since each elements such element are called the zero divisor, for an element A belongs to R and a non-zero element called the zero divisor, there exists some other element, non-zero element, that is the product of the two non-zero elements should be equal to 0 now. Then that is that element as is called the zero divisor அப்படின்னு அர்த்தம். So அதனால Z6 is not a field, Z6 is not a field, and so that is the field as no zero divisor, very important point, field as no zero divisor, and here as the zero divisor, so contains a zero divisor 2 into 3 equal to 6, that is Z6 is not a field, but Z7 is the field. Z7 is the field because of the P is 7 is the prime number, so prime number modulo வர்றது எல்லாமே field இருக்கும் over the integer. Okay, so finite field இருக்கும் over the integer. So Z by Pz is a field with P is a prime, P is a prime, and zero divisor can exist here in ring that not a field, but not a field. Modular arithmetic concrete example for the abstract ring concept, and prime modules modulo 7 prime modules, that is a field no zero divisor. Modulo 6 ன்றது composite number, ring with zero divisor, not a field. And a ring of 2 by 2 matrices, this is not a 2 by 2 matrix, this is a symbol, that's a like collection that is isomorphic to the ring of 2 by 2 matrices. That is an interesting one. So R be the set of all symbols of the form, formal expression of the form alpha 1 1 E1 plus alpha 1 2 E2, alpha 2 1 E21, alpha 2 2 E2. இது எப்படி எக்ஸ்பிரஸ் பண்ணலாம், summation I, j 1 equal to 1 to 2 alpha ij ej னு எக்ஸ்பிரஸ் பண்ணலாம். that the entries belongs to Q, rational numbers. இதை வந்து முதல்ல டிஃபைன் பண்ணியிருக்கிறோம், like this set of all symbols like this டிஃபைன் பண்ணியிருக்கிறோம். So the both are equality is old, ரெண்டுமே எப்போ ஈக்குவலாக இருக்கும்னா the corresponding EIJ நோட கோஎஃபிஷியன்ட் ஈக்குவலாக இருந்தால் for I equal to j, I equal to 1 to 1,2 and j equal to 1,2க்கு equal. So how to define the additionன்றதை like this, the corresponding alpha ij beta ij into EIJ ன்னு டிஃபைன் பண்ணலாம். ப்ராடக்ட்ன்றது gamma ij ன்னு டிஃபைன் பண்ணலாம். gamma ij ன்றது என்னவா இருக்குன்னா the product of alpha ij and beta ij வா இருக்கலாம். So this is the gamma ij is the defined as summation gamma iv and beta vj. This is a product, and multiplication rule apply பண்ணீங்கன்னா multiplication is based on the following rules, that is eij ekl equal to 0 for j is not equal to k. So like this define பண்ணலாம் multiplicative, and eij ejl equal to eil. this corresponds exactly to matrix multiplication. EAJ represent the matrix with 1 in position I comma j and 0 elsewhere. So matrix interpretation pathina, and the ring is isomorphic to the ring of all 2 by 2 matrices over Q. So this is the isomorphic to alpha 1 1 and alpha 1 2, alpha 2 1, alpha 2 2. So this is the A equal to E11 minus E21 plus E22. So but B equal to E22 plus 3 E12. So then this is A dot B equal to like this, இது மாதிரி multiply பண்ணலாம். இதில் using the multiplication rule apply பண்ணீங்கன்னா E11 E22 equal to 0, that is 1 is not equal to 2ன்றதுனால 1 is not equal to 2, this is the 1 equal to 1 இது, அதனால E12 define பண்ணலாம். இங்கே 1 is not equal to 2, அதனால 0. இங்கே 1 is 1 equal to 1, அதனால E22. So இங்கே ரெண்டுமே ஈக்குவலாக இருக்குது, E22. So this is the 2 equal to 1, 2 is not equal to 1, so அதனால 0. So like this multiplication rule, இது apply பண்ணீங்கன்னா this is become the A dot B equal to like this, இது மாதிரி கிடைக்குது. So this is a E11 E12 equal to E12, but E12 E11 equal to 0, so this is not multiplicative, sorry, not commutative. Not commutative is non-commutative ke idu example idu. And a non-commutative ring ku, this is the example. This is isomorphic to set of integers, sorry, that is a collection of 2 by 2 matrices, E12 and E21 equal to E11. So this is not equal to 0, and E12 E11 equal to 0, so both are not equal to 0, that is a 0 divisor exist ஆகுது. Unity element பார்த்தீங்கன்னா the element act as the unit multiplicative identity. So E11 E22 into some element multiply பண்ணும்போது உங்களுக்கு கிடைக்கிறது அதே element வருது. So multiplicative identity exist ஆகுது. This is the multiplicative identity. So இது உங்கள் எஸ்டின் புக்கில் இருக்கிற ஒரு ப்ராப்ளம் தான் இது. ஓகேவா, நியூ ப்ராப்ளம் நான் வேறு எங்கேருந்து எடுக்கல. So this is the example for non-commutative ring. So little bit complicated ஆன ஒரு example இது. So this is the non-commutative ring example, and with 0 divisor. This is isomorphic to set of 2 by 2 matrices with the entries belongs to the real number. And a complex number as a field, set of complex numbers, C be the order pairs of the real numbers. The collection of alpha beta belongs to R. இங்கே ஈக்குவாலிட்டி ரெண்டு காம்ப்ளெக்ஸ் நம்பர் எப்போ ஈக்குவலாக இருக்குன்னா கரஸ்பாண்டிங் ரியல் அண்ட் இமேஜினரி பார்ட் ஈக்குவலாக இருந்தால் ஈக்குவலாக இருக்கும். அடிஷன் வந்து ஜஸ்ட் சிம்பிளாக ஆட் பண்ணுவோம். அண்ட் மல்டிப்ளிகேஷன் எப்படி மல்டி பண்ணுவோம், ரியல் அண்ட் ரியல், இமேஜினரி ரியல் மல்டிப்ளை பண்ணுவோம். அண்ட் அடிட்டிவ் இன்வர்ஸ்ன்றது நெகட்டிவ் ஆஃப் த காம்ப்ளெக்ஸ் நம்பர் தான், இட்ஸ் நாட் அ ப்ராப்ளம். ஸோ அண்ட் வித் ரெஸ்பெக்ட் அடிஷன் இஸ் த மல்டிப்ளிகேஷன். அண்ட் மல்டிப்ளை பண்ணுறது நமக்கு தெரியும், ரியல் இன்ட்டு ரியல், இமேஜினரி, ரியல் இமேஜினரி ரியல், தென் ஒன்லி ரியல் பார்ட் இமேஜினரி பார்ட் செப்பரேட்டாக கிடச்சிரும் நமக்கு. ஸோ த க்ளோஷர் சாட்டிஸ்ஃபை ஆகும். அண்ட் ஆல்சோ அண்டர் த மல்டிப்ளிகேஷன் கம்யூனிட்டி ப்ராப்பர்ட்டி x dot y, y dot x both are சேமாக இருக்கும். அண்ட் unity element 1, 0, 1 plus I 0. So unity element under the multiplication exist ஆகுது. So this is an example for field because of every non-zero element has a inverse. Inverse is the form of alpha plus I beta நோட inverse பார்த்தீங்கன்னா that is alpha by alpha square plus beta square comma minus beta by alpha square plus beta square. So this is the inverse, the 1 by alpha plus I beta ன்னு சொல்லுவாங்க. காஞ்சுகேட் எடுத்து சிம்பிளை பண்ணிங்கன்னா we get this one. This is equal to 1 by alpha plus I beta. Okay. So conjugate எடுத்து சிம்பிளை பண்ணிங்கன்னா this is called the inverse. Okay. So complex number, this is the interpretation, is a field. Set of complex number is a field. Field example, field is isomorphic to the complex numbers. And a ring of real quaternions, this is also another example. Quaternion is expressed, is of the form alpha naught alpha 1i plus alpha 2j alpha 3k. இதிலேயே ஈக்குவாலிட்டி டிஃபைன் பண்ணலாம். ரெண்டு ஈக்குவல் மீன்ஸ் கரஸ்பாண்டிங் கோஎஃபிஷியன்ட்ஸ் ஆர் ஈக்குவல், தென் ஒன்லி ஈக்குவல். அடிஷன் டிஃபைன் பண்ணலாம். ஸோ லைக் திஸ் ஆல்ஃபா நாட் கரஸ்பாண்டிங் ஐஜேக்கு கோஎஃபிஷியன்ட் ஆட் பண்ணணும், கான்ஸ்டன்ட் டேர்ம் ஆட் பண்ணணும், தட் இஸ் அடிஷன். மல்டிப்ளிகேஷன் எப்படி டிஃபைன் பண்ணலாம்னா காம்ப்ளெக்ஸ் நம்பரில் போட்ட மாதிரி தான் போடணும். ஆனால் இங்கே 4 டேர்ம்ஸ் வரும். ஓகே, அங்கே ரெண்டே டேர்ம் இருந்தது, இங்கே 4 டேர்ம்ஸ் வரும் மல்டிப்ளிகேஷன். ஸோ திஸ் இஸ் த மல்டிப்ளிகேஷன். and quaternion is the multiplication rule வந்து பார்த்தீங்கன்னா this is the multiplication rule I square j square k square and ijk equal to minus 1 ij equal to k jk equal to I kj equal to j that is cyclic வந்ததுன்னா அதே ரிவர்ஸில் திருப்பினீங்கன்னா மைனஸ் வரும் ஓகேவா ஸோ சைக்ளிக் டயக்ராம் பிரகாரம் இதை ஞாபகம் வச்சுக்கலாம் this is the cyclic diagram and the elements பார்த்தீங்கன்னா quaternion unit groupல elements is of the form plus or minus 1 plus or minus I plus or minus j plus or minus k form a non-abelian group of order 8 under the multiplication. So the quaternion group Q8 Q8 ன்றது ஆல்ரெடி group 3 ல டிஸ்கஸ் பண்ணிருக்கோம். இதனுடைய 0 element பார்த்தீங்கன்னா 0 equal to 0 plus I0 unity element பார்த்தீங்கன்னா that is unity element 1 plus I0 ij 0j plus 0k. So unit element is 0 plus I0 j0 k0. It's a non-commutative because of ij and ji both are not equal. So but under the multiplication this is not commutative. So this is the non-commutative ring with unity ki or example that is called the quaternion group. This is the quaternion group is example. And division ring structure, the division ring for any non-zero quaternion ring that is non-zero element beta equal to something, define the beta equal to the multiplicative inverse is y equal to alpha naught by beta minus alpha 1 by beta minus alpha 1 divided by beta I minus alpha 2j minus alpha 3 by beta and a and k. Then x dot b is defined as so x dot y is defined as alpha naught alpha 1i alpha 2j alpha 3k into that y multiplicative inverse. When you multiply this one we get it 1 by alpha naught square something equal to 0i 0j 0k that is called 1. That is the multiplicative identity exists for non-zero element. So this is the example for the division ring. Quaternion ring is a quaternion group. The quaternion is defined as the division ring. Division ring means a ring in which every non-zero element has a multiplicative inverse. Commutative division ring is called the field, but quaternion ring is not a field, but that is a division ring. Okay. So Q is a non-commutative division ring. Non-commutative division ring Q என்றது because of commutative property satisfy ஆகுது ij is not equal to ji என்றதுனால. So this is a very good example non-commutative division ring example வந்து Q என்றது quaternion group. ஓகேவா இதை நீங்கள் படிக்கும் பொழுது இல்லை பார்க்கும் பொழுது கண்டிப்பாக ஹெல்ப்ஃபுல்லாக இருக்கும்னு நினைக்கிறேன். So non-zero element non-abelian group and this is a table that is a discussion of ring of integer modulo 7 is a commutative ring and division ring and the field, but integer modulo 6 into commutative ring but not a division ring and this is a commutative ring. Okay, and 2 by 2 matrices not a commutative ring and not a division ring. Okay, and complex numbers commutative ring and a division ring and this is a field set of quaternion not a commutative ring not commutative but it's a division ring. This is the example for a division ring. Okay, where this table is very useful to you. And another one pathina there is the definition for the zero divisor already discussed pannom. So zero divisor R is a commutative ring with then an element A belongs to R. Non-zero element is said to be zero divisor if there exists B belongs to R, B is not equal to 0 such that A dot B equal to 0. For example, Z6 in Z6 la pathina 2 into 3 equal to 0. Zero divisor exists in Z6. ரெண்டு non-zero element multiply பண்ணா zero divisors in Z6 வந்து 2 3 4 2 3 4 are zero divisors of Z6 and in a ring 2 by 2 matrices real matrix M2 of R ரெண்டு non-zero element multiply பண்ணீங்கன்னா that is a zero element வரும் that is called the zero divisor exists in the collection of 2 by 2 matrix with real entries, and a direct product Z2 cross Z3 are equal to 1 comma 0 and 0 comma 1 both are belongs to R. When you multiply it 0 comma 0, so the zero divisor exists in the Z2 cross Z3. In Z15 0 1 2 up to 14, so 3 into 5 into the 15 modulo 0, so Z15 is the zero divisor exist agum. So this prime number illa அப்படினா கண்டிப்பா zero divisor exist ஆகும். That is not a field. Prime number இருந்தா that is a field, no zero divisor ன்னு அர்த்தம். Okay, so A is a zero divisor in Zn எப்பனா if and only if GCD of A comma n is not equal to 1 ஆ இருந்தா. So GCD of A comma n equal to 1 ஆ இருந்ததுனா that is n is the prime number ஆ இருந்தா this is the field. அதே மாதிரி no zero divisor in an integral domain. So integral domain means ZQ or C AB equal to 0, either A equal to 0 or B equal to 0, then ZQ R la. So then these rings without zero divisor called the integral domain. So zero divisor ilna, that is called the integral domain. Integral domain ku example. So this is zero divisor edukla exist agudunu kuduthirkom, and in a field or an integral domain no zero divisor exist. Field liyum integral domain liyum zero divisor exist agadu, and in Zn la zero divisor is exactly those elements that are not co-prime to n. Okay, so existence of the zero divisor prevents cancellation in multiplication. Existence of zero divisor prevents the cancellation in multiplication. That is also a very important point. A zero divisor in a non-zero element that can multiply with another non-zero element to provide 0, and is a 6 example already discussed pannom. And commutative ring or with unity is called the integral domain appdi na solnona. It has the no zero divisor. It has no zero divisor. edukla zero divisor illan paathom, so adha vechi which is called the integral domain appdin sollalam. Once again, ring of integers is called the integral domain. No zero divisor. Real numbers integral domain because of it has no zero divisor. Ring of complex number is an integral domain. No zero divisor. Set of ring of polynomial R of x is an example for the integral domain. Ring of integer modulo prime p, only prime p. Composite number and it's not integral domain. So prime p is an integral domain, and Z6 for example Z6, that is called the not an integral domain. Z6 is not an integral domain because of this 6 is the composite number. This is not an integral domain. So integral domain radhukku example pathina ZQ or C, okay, by ZP R of x is called the integral domain. Not an integral domain radhu Zn is a non-prime n. This is not an integral domain. அதே மாதிரி division ring ன்றது already பார்த்தோம் little bit. That is every non-zero element, but it's not, need not be a commutative. So every non-zero element in R as a multiplicative inverse, that is called the division ring. Commutative ring with unity, every non-zero element has a multiplicative inverse, that is called the field. That is called the field. So in multiplicative is commutative now, that is called the division ring is called the field. Division ring is field. So ரொம்ப clear cut இருக்கணும் இதெல்லாம் ஐடியா. ஓகே, எந்த காலத்துலையும் எந்த நேரத்துலையும் குழப்பமே வரக்கூடாது. So the field of real numbers, இதுக்கு எக்ஸாம்பிள் பார்த்தீங்கன்னா field of real numbers, field of complex numbers. Okay, complex numbers, these are example for the field, and the field of rational numbers, this is the example for Q is a division ring also, and quaternions is of the form alpha 1 alpha 2 potom. Okay, bi cj dk, and this is I square plus j square plus k square equal to this is equal to finite field. Zp is a commutative division ring, that is the field example, but Z6 is not a field, so the division ring and field, and Q or C Zp ன்னு சொல்லுவோம். quaternion non-commutative division ring. The table மட்டும் பார்த்தீங்கன்னாவே it's a very useful one. Okay, and not a division ring க்கு Zn ன்றது example. Okay, and the field ன்றது பார்த்தீங்கன்னா there is the commutative ring with unity and every non-zero element has a multiplicative inverse is called the field. Okay, already discussed about it. And the field of real numbers, field of complex numbers, field modulo is a pre. So the same example once again. Rational function is a real coefficients. That is R of x is a field and Z6 is not a field. So this is the example. Q or C is a P R of x is a example for the field. Every field is an integral domain, but not every integral domain is not a field. This is a very important point. Every field is an integral domain, but not every integral domain is a field. கொஞ்சம் கான்செப்ட் கிளியராக இருந்தீங்கன்னா கூட இதெல்லாம் கேட்ச் பண்ணலாம். ஞாபகம் இல்லைனா கூட கொஞ்சம் திங்க் பண்ணி ஆன்சர் பண்ணலாம். ஃபார் எக்ஸாம்பிள் Z is an integral domain but not a field, because not every non-zero integers has a commutative multiplicative inverse. Okay, but there is a idea inverse in Z. So that is the integral domain but not a field, a set of integers. This is the example. At least the example ஞாபகம் வச்சுட்டா கூட நீங்கள் ஞாபகம் வச்சுக்கலாம். Okay. And this is the table, integer set of integer. This is the commutative ring. This is the division ring. And no division ring, no field, and integral domain, but it is integral domain. Adhe mari even integer is the commutative ring, not a division ring, and not a field but integral domain. And rational numbers is the commutative ring, division ring, and field and integral domain. And integer Z7, Z by 7, modulo 7 is the commutative ring and division ring, and this is the field and the integral domain. But integer modulo 6 is the commutative ring and a division ring, not a division ring, and not a field and integral domain, not integral domain. 2 by 2 matrix node collection. இதில் எதுவுமே satisfy ஆகாது. That is the complex number is all of them. Quaternion வந்து not a commutative ring, but it is a division ring and not a field. Okay, and not a integral domain, So this is a very, very important table, final table. Okay, and field implies integral domain. Every field is integral domain. Every integral domain is a commutative ring. This is also very important one. And every field is a division ring. Every division ring is a ring. Every division ring plus commutative property is a field. Integral domain plus division ring is called the field. That is also very, very important. And this is a very basic properties. இது ஃபெமிலியராகவே நம்ம ஈக்குவலாக இருப்போம், ஒன்றும் பிரச்சனை இருக்காது, டெஃபினட்டாக கேட்க மாட்டாங்க. அண்ட் ஃபைனட் இன்டெக்ரல் டொமைன் இஸ் அ ஃபீல்டு. ஃபைனட் இன்டெக்ரல் டொமைன் இஸ் அ ஃபீல்டு. இதுக்கெல்லாம் எக்ஸாம்பிள் ஞாபகம் வச்சுன்னா நீங்கள் இந்த கான்செப்ட் ஞாபகம் வச்சுக்கலாம். ஃபைனட் இன்டெக்ரல் டொமைன் இஸ் அ ஃபீல்டுனா ZP is a prime number, is a field. Okay, but Zn is not a field. Zn is not a field. Zn is a n is a not composite n is not an integral domain as zero divisor, not a field. Okay, not an integral domain kandipa not a field. Remember, this is the example. Example Z2, Z3, these are example for the field. Z5 is also example for the field. F4, the field of order 4, 2 square, that is a prime P square, that is can be constructed as F4 equal to 0, 1. இது CSIR net கொண்டா இவ்வளோ காம்ப்ளிகேட்டடாக கேட்பாங்க. F4ன்றது that is 0, 1 alpha plus 1. So alpha satisfy the irreducible polynomial alpha square plus alpha plus 1 over Z2. This field has no zero divisor. It's a finite integral domain. And Z6 is not a field and has zero divisor. So this is the example for finite integral domain is a field examples. So z2 and z3 இதெல்லாம் prime number, f4 f9 that is the 2 square, இது வந்து 3 square, order வந்து 3 square. Zn n is composite, that is not an integral domain. So simple idea. And so every finite integral domain is automatically a finite field. The only finite examples of integral domains are Zp, and finite extension is Fp power n. Finite extension is Fp power n. This is a very important idea. And corollary, that is every finite field has a prime power. Every finite field has a prime power order, that is p power n. Adukku example, that is the z2, and once again z2. The same example are because of for your understanding. Okay, z2 and that is the multiplication table and addition table போடலாம். So easier z2 is a field in சொல்லலாம். z5 is also field. z3 is also field. Finite field of order 4, alpha square equal to alpha plus 1. Satisfy the polynomial alpha square equal to alpha plus 1. This is alpha plus 1 whole square equal to alpha. The f4 is the example for the finite field with the 4 elements. f9 is also z3 of x divided by x square plus 1. X square plus 1 is irreducible polynomial over z3. So the elements of the form a plus bx, a comma b belongs to z3. So this is the example, that is the z2 is the field of order 2, is the field of order 3, field of order 5, field of order 2 square, field of order 3 square. This is the construction. Z2 of x divided by x square plus x plus 1. This is the 3x divided by x square plus 1. This is the prime field modulo 5, this is the prime field modulo 3, this is the prime field modulo 2. So the fundamental in algebra, that is the finite field or fundamental in algebra, and that is coding theory, cryptography, like this. Every finite field has of order p power n. Every finite field of order p power n, p is a prime, n greater than equal to 1. Field of prime order or of the form Zp, and fields non-prime orders are commutative constructed quotient ring of polynomials ring over Zp. So p is a prime number, Jp, the ring of integer modulo p, is a field. And so this is the field with finitely many elements are called the finite field or Gauss field. Jp gives the finite field, and Fb the field with the additive identity 0, multiplicative identity 1. And characteristic of F, it's a very important concept. Characteristic of F, how to define, that is define the smallest positive integer n such that n into 1 equal to 0, that is 1 1 plus 1 plus 1. So if no such n exists, then we say that a field has the characteristic 0. So characteristic of F, how to define, that is n, if n is the smallest positive integer satisfying the n into 1 equal to 0. Otherwise no such n exists, that is the characteristic is 0. It's a very important concept. The field for the field Z2. So what is the characteristic of 1 plus 1 equal to 0 inga. Appadina the characteristic of Z2 is 2. Characteristic of Z2 equal to 2 because of 1 plus 1 equal to 0. So the n is 2 here. The same way Z3 ki 1 plus 1 plus 1 equal to 3 equal to modulo 3 plus 0. So characteristic of Z3 equal to 3. And the same way for the field Z5, characteristic of Z5 equal to 5. What about the finite field F4? F4 is defined 0 1 alpha alpha plus 1 is constructed over Z2 using the irreducible polynomial x square plus x plus 1. Since its base field is Z2, the characteristic is 2. So characteristic of F4 equal to 2. Characteristic of F4 is 2. அதே மாதிரி field of rational numbers Q. Rational numbers Q வந்து is always எந்த 1 plus 1 n என்றது 0 ஆகாது. So no positive integer n is exist for the field q அப்படினா என்ன characteristic of q ன்றது 0, characteristic of q equal to 0. The fields r and the complex number c, field r and complex number c இது மாதிரி ஒரு exist ஆகாது. So characteristic is 0, characteristic is 0 for the set of real number and complex number. This is table பண்ணிருக்கோம். And the characteristic of the field is either 0 or prime number. That is the idea from the table. Finite field always have the prime characteristic. Field of characteristic 0 contains a subfield isomorphic to q. It's a very important point. Okay, but the characteristic field of characteristic 0 contains a subfield isomorphic to q, and the field of prime characteristic p contains a subfield isomorphic to zp. Okay, and if an integral domain has a finite characteristic, then its characteristic is prime number. Then the characteristic is prime number. It's also very very important. Integral domain has a finite characteristic now. That characteristic should be prime number. And so the why restrict to integral domains? That is for the arbitrary rings. Is it true? That is a ring is constructed. And so this study, the example for the ring is of the form Z2, that is Z2 cross Z3 cross some Z. That is constructed like that. How to define the addition and இது மாதிரி addition வந்து define பண்றோம். R என்றது ABC, A என்றது Z2 ல இருக்கு, B என்றது Z3 ல இருக்கு. B என்றது Z3 ல இருக்கு, C என்றது Z ல இருக்கு. Okay, so the collection of the set R A B C, addition ன்றது like this இது மாதிரி define பண்றாங்க. இது வந்து modulo 2 Z2 ல இருக்கும். modulo 2 செக் பண்ணனும், இதுல modulo 3 செக் பண்ணனும், இது எதுவும் செக் பண்ண வேணாம். இதே மாதிரி same thing product define பண்ணிருக்காங்க. So that is the R is a commutative ring with unity. We can verify easily. This is a commutative ring with unity. 1,1,1, and because of multiplication like that define பண்ணதுனால this is not an integral domain. Because of ரெண்டு non-zero element multiply பண்ணீங்கன்னா 0 வரும், 0 divisor exist ஆகும். And the behavior of the multiplicative elements, behavior of multiples of elements. Let us examine what happens when we add the elements. That is 1 plus 1 equal to 0, 2 into 1 0 0, that is equal to 0, 3 into 0 1 0, that is 3 into modulo 3 அதனால 0, modulo 2 அதனால 0. So there is no positive integer n such that n dot 1 equal to 0. So that what is the conclusion? That is characteristic of this one is 0. Okay, characteristic of from this above conclusion, this is equal to characteristic of R is not well defined, so there is a characteristic of this one is 0. So that characteristic of definition of the characteristic for the integral domain assume that the existence of the single number n dot 1 equal to 0, but here R equal to the ring, in the ring Z2 the Z2 cross Z2 ne போட்டுருக்கலாம். This is the Z2 Z3 cross Cartesian product of this int cross Z behave differently. That is a characteristic of Z2 2, characteristic of Z3 3, characteristic of Z equal to 0. So no global characteristic, no global characteristic exists. This concept is little bit high. That is for an arbitrary ring, okay, can define the local characteristic. That is the concept of n torsion. This is called the n torsion. And how to define the n torsion? N greater than, there exists an element A is not equal to 0 in R such that NA equal to 0, but MA is not equal to 0. M is lies between 0 and n. So generalize the idea characteristic beyond the integral domains. Integral domains and the finite characteristic. The integral domain D as n torsion some n greater than 0, D must have the finite characteristic. D must have the finite characteristic. That is how to define that it follows from the torsion in domain implies the global additive order for the unit element. So that means or as a n torsion, already we know the definition. So for an integral domain D, if D has an n torsion for some n greater than 0, D must be finite characteristic. Okay. So the characteristic, very simple idea. So now ZQ or C இதனுடைய characteristic பார்த்தீங்கன்னா 0. இது எல்லாமே infinite field, and JP, that's nothing but the ZP is a prime power, that a prime P is a characteristic, it's depend on the P, and this is the finite field example. Zn, this is the n is composite, the characteristic n, not an integral domain, and finite field of order P power n, characteristic P, okay, the characteristic P, and existence for all prime powers, and this is the J2, J3, Jn. இதான் இப்போ பார்த்தோம். இது characteristic not defined. This is the mixed torsion. This is the example for the mixed torsion. Okay. So அதனால தான் integral domainல இது integral domainக்கு வந்து characteristic வந்து define பண்றாங்க, not for the ring. அதுக்கு தான் அந்த n torsion example. So characteristic 0 fields behave like rational numbers. Prime characteristic fields have a arithmetic modulo P. Fields finite field என்றது, that is a example. The mixed characteristic என்றது number theory and algebraic geometry ல யூஸ் பண்றாங்க. Finite field என்றது crucial coding theory and cryptography and combinatorics. And a definition of ring homomorphism. This is the ring homomorphism means already நம்ம group theory ல homomorphism define பண்ணோம். Like that, the same idea, but ஆனா இங்க ரெண்டு ஆபரேஷன் இருக்கு, plus and dot. அதனால pi of a plus b equal to pi of a plus pi of b, pi of a b equal to pi of a into pi of b. Na, when you define the sum mapping from R to R dash, the ring homomorphism is called, this is called the ring homomorphism. And ஏன் ரெண்டு operation use பண்றாங்கன்றது the clarification here. So that is a connection to the group homomorphism. This is okay, that's all. So isomorphism the same way defined for that same way for in group theory எப்படி define பண்ணணும், like that இங்கேயும் வந்து isomorphism define பண்ணணும், that is with one to one and on to homomorphism, ring homomorphism is called the ring isomorphism. Okay, thank you.